World Models, the Next AI Frontier. Executive Summary. World models represent the next essential frontier in artificial intelligence development. These systems build an internal, simulated understanding of real-world physics and causal relationships. Current AI often struggles with common sense and requires huge data sets for slow learning. World models overcome these limits by allowing the AI to dream and practice actions internally. This efficient imagination enables rapid learning and sophisticated planning. This technology will unlock safer autonomous vehicles, more adaptable robotics, and highly realistic training simulations, driving us toward truly general artificial intelligence. Artificial intelligence now performs incredible tasks. It writes poems, codes software, and drives cars. Most modern AI focuses on pattern recognition. These systems examine massive amounts of data. They predict the next word or the correct image label. However, this method has serious limitations. A new concept is emerging in AI research. Scientists call this concept a world model. This technology aims to give AI a genuine understanding of reality. World models may mark the next critical step toward creating truly intelligent machines. They will revolutionize how machines learn, reason, and interact with the world around us. What is a world model? A world model is an internal simulation of the environment. Think of it as a machine's imagination. Humans constantly use their own internal world model. You predict where a thrown ball will land. You estimate how much time a specific task will take. You perform these calculations mentally, without conscious effort. World models give this same powerful ability to AI. The system observes its surroundings. It builds a compressed mental map of the world's physics and dynamics. It learns how objects move. It understands how its own actions cause changes. The AI can then run internal simulations. It predicts the results of various actions before taking any physical steps. This internal planning replaces much of the slow, real-world trial and error process. The limitations of current AI systems achieve great results in narrow fields. Large language models, or LLMs, dominate the digital world. They are highly skilled at processing and generating human text. These models lack a deep understanding of cause and effect. They often struggle with common sense. They cannot reason about physical space or object permanence. For example, a language model knows the word gravity. It does not feel the force of gravity or understand its implications for a falling object. Current AI also learns very inefficiently. It requires huge data sets to train. A self-driving car must drive millions of real-world miles to learn simple navigation. The slow process costs enormous amounts of money and time. Researchers must overcome these fundamental limits. World models offer a necessary solution to this data dependence and lack of genuine comprehension. The three core components. A successful world model architecture generally contains three major parts. These three modules work together constantly. The vision model acts as the first component. It perceives the raw input, often visual data like video frames. It then encodes this high-dimensional information. It converts the data into a simpler, compressed representation called the latent space. This compressed state captures only the essential information. The memory model forms the second critical part. It uses a recurrent neural network to process the compressed data over time. It keeps track of past states. It learns the temporal dynamics of the environment. Most importantly, it predicts the next state of the world based on the current state and a proposed action. This predictive ability forms the core of the world model. The final component is the controller. It is a small decision-making policy network. The controller uses the compressed predictions from the memory model. It decides the best action for the agent to take. It learns optimal strategies directly within the simulated internal world. This design allows the AI to perceive, predict, and then act intelligently. learning through internal imagination. The ability to plan internally is the major benefit of world models. Traditional AI agents learn only through direct interaction with the environment. They must collect millions of training samples from the real world. This reliance makes the learning process very slow. World models dramatically change this learning method. The agent collects some initial real-world data. It then uses this limited data to train its internal prediction model. The AI then enters a dreaming or imagination phase. During this time, the agent generates massive amounts of synthetic data. It simulates countless scenarios inside its own mind. It practices diverse actions without needing real-world input. This internal imagination allows for massive computational efficiency. The AI learns complex behaviors much faster. Imagine training a robot to stack blocks. A traditional robot would knock over the blocks many times in the real world. A robot using a world model only knocks over the blocks in its simulation. It refines its strategy internally before making any physical movement. This speed and safety are crucial for real-world applications. Real-world applications and the future. World models hold great promise for numerous applications. Robotics will undergo a massive transformation. Robots can currently perform repetitive, programmed tasks. World models allow robots to handle unexpected situations. A robot in a factory can adapt quickly if a tool falls or an object moves. Autonomous vehicles will also become much safer. A car equipped with a world model predicts the future actions of other drivers and pedestrians. It anticipates potential crashes seconds before they happen. This predictive power enhances safety significantly. Beyond physical machines, world models will revolutionize simulation. Companies are developing vast, interactive virtual worlds. These environments require accurate, consistent physics and logic. World models ensure that virtual objects behave naturally. They guarantee that gravity works the same way every time. This consistency is essential for high-fidelity training simulators. Pilots can practice emergency landings in realistic simulations. Surgeons can perform complex operations hundreds of times safely. Experts believe world models are the key to unlocking true artificial general intelligence (AGI). AGI refers to a machine with human-like cognitive abilities. World models provide the necessary framework for reasoning and comprehension. They represent a fundamental shift from pattern matching to genuine understanding. The race to build the ultimate world model will certainly define the next generation of AI research and development. This technology will shape our future in profound and surprising ways. We stand at the edge of this new technological frontier.